have the circuit right in front of us. So the first step was to identify the nodes, okay? So this is one node right here. This node, I'm gonna label it as VA. This connects the current source, 8 amps in the resistor R1, okay? Then we have this node right here. I'm gonna label it as VB. This is gonna be our VC. This is going to be our VD, and then the common node right here, VE here. Remember, this VE is going to be equals to 0. Let's now look at the flow, the direction of the current. We know we have this current source here. The current will go here, flow in this direction, and then go here down. Similarly, we have 50 volts over here. The current will flow in this direction and then go this way. Okay, now there's a tricky part. The tricky part is, what will be the direction of the current across this resistor over here? And also, let me just finish the labeling here. So this was R1, this is going to be R2, this is going to be R3, you have R4 here, and then finally you have R5. What is going to be the direction of the current? Is that going to be from VB to VC like this? Or is it going to be VC to VB like this? Any thoughts? Yes, folks. How would we know what is the direction of the current flowing across the resistor R3? Because it could be both ways. We don't know the potential here at VB. We don't know the potential at VC. So we would not know which potential is higher. You know, our thinking is that the direction of the I3 is dependent upon the values of VB and VC, correct? Okay, so if VB is greater than VC, then the direction of the I3 is going to be like this, correct? If VB is less than VC, then the direction will be the other way, okay? Because it is not entirely known from this circuit at this point, we're gonna do a rough approximation, okay? And before we get onto that rough approximation, let me just, try to follow all these steps. So the first step was to identify the number of nodes. So here, how many nodes we have? V, A, B, C, D, and E. So we have 5 nodes over here. So we have number of nodes are 5. Solving for easy nodes, solving for easy nodes. Here we have I1, which is gonna be flowing across the R1 here, I1. I1 is 8 amps, right? You have 8 amps. So I1 is going to be 8 amps. Also, we know VD here is going to be 50 volts, right? It's connected to the positive terminal of the battery. So VD is going to be 50 volts. VD is 50 volts. And also VE we know is going to be 0 volts, okay? Because it's connected to the ground. The third step, which is the final step, apply KCL, okay? At nodes. Okay. Yeah, sorry about the noise in the background if you hear any. The landscaping folks are here. Okay, all right. Now, how do we find out, coming back to how do we find out what is the direction of the current, whether it's going this way or it's going this way? So for a little amount of time, I'm actually going to remove this resistor, okay? And then break this circuit into 2 parts, one on the left of it and one on the right of it. So if I redraw the circuit, it will look something like this. Correct? So this is going to be R1, this is going to be R2. I have 8 amps over here. And the right part of the circuit will look something like this. This is your 50 volt source. Remember, this is your VB here. this is your VC here, this is your R5, this is your R4, okay? I need to find out VB and VC. I need to find out VB and VC. So for VB, what I could do here, yes, how can I calculate VB? Can I just simply apply Ohm's law here? Yes, I can. So I get what? VB equals to, remember I is in a series circuit remains same and it's already given, which is 8 amps. Yeah. VB equals to I times R2, okay, whatever the voltage is across this resistor, that's the voltage at this node, VB IR2. I being 8 amps, R2, the value of R2 is 5. So VB is 40 volts, okay? Similarly, I'm going to find out VC now, and I can just simply apply voltage divider, okay? Remember folks, voltage divider, current divider, Ohm's law, these are the techniques that you could use to get the values for voltages and currents across the components. So again, VC is the voltage that is across R4 here. So VC equals to total voltage supply, which is 50, times the component across which you are trying to find the voltage, which is R4, divided by total resistance, because it's a series circuit. So the total resistance is going to be the sum of R4 and R5. Let's plug in the values. 50 is for the VS, R4 is 4 ohms, and then R5 was how much? R5 was 10 ohms, correct? Okay, so 10 plus 4 plus 4, here I get 20, actually 250 times 4 is 200, divided by 14. If you do the math, you roughly get 14.29 volts. Okay, now remember here folks, these are not the exact voltages at these nodes VB and VC. These are just rough estimates. Okay, so if I plug in these values, VB is going to be 40 volts here, okay, and then VC here is going to be 14.29. Now if I ask you, what is the direction of the current going to be? Yes folks, based on this approximation, obviously VB is greater here, right? Our analysis from here is that VB is greater than VC. These are the approximate values, VB being 40 and then VC being 14.29. And we had initially determined if this is going to be the case, then the direction of the current is going to be from left to the right. So the direction is going to be like this. Okay. All right, cool. It's going to be like this because this is going to be high potential. Now let's, start working on the circuit back again. I'm gonna, zoom in a little. Okay, we're gonna start off by the color. Yeah, let's do this. At node KCL at node B. At node VB. Okay, all right. And again, it looks something like this. Okay, this is your node VB in the circuit. You have I1 coming in. Okay, you have I3 here. Okay, it's flowing in this direction, and then you have I2 here that's flowing in this direction. Okay, so what would be your equation? KCL, current entering the node equals to current leaving the node, which would give you equation I1 equals to I2 plus I3, correct? Okay, I1 we know, I1 which is here, this is 8 amps, correct? So you get 8 amps here. I2, which is the voltage across this resistor right here, okay? This is going to be the potential difference of the VB and VE, right? Remember VE is 0. So I just simply apply Ohm's law. So I get what? VB minus VE. VB minus VE over R2. R2, yeah. And then I3 is this right here. This is going to be R3. Okay, I3 is going to be, because in the direction of the current is such, so the voltage across this resistor is going to be the potential difference of VB and VC. So I get VB minus VC over R3. Okay, all right, cool. I'm going to plug in the values here now. So I have 8 amps here equals to VB is something that we are looking for. VE is 0, so VB minus, I can just simply write VB over R2. What is the value of the R2? R2 is 5 ohms, so I get 5 ohm here, okay, plus VB minus VC over R3. R3 was how much? 5 ohms also, okay. So this is going to be 5 ohms. And say if I multiply this whole equation by 5, so I get what? 40 amps equals to VB plus VB minus VC, correct? If I rearrange this equation, I basically get 40 amps equals to 2 VB minus VC. And I'm gonna say this is my equation 1. Okay, let's now apply KCL at node C. Okay, at this node right here. Now apply KCL over here. So I'm gonna say applying KCL at node VC, and again I'll put it down something like this, just for the sake of explanation. Again, remember this is your VC node. Okay, so the current entering is I3 here, okay, and then I5, okay, I3, I5, and then current leaving, that's I4, right? That's the I4. I4. So if I make an equation, it will look something like that. I3 plus I5 equals to I4. Remember, I3 is the potential difference between VB and VC, right? VB and VC. So this will be I3 will equals to V over R, V being potential difference between VB and VC, over R3, I5. What is I5 here? Okay, I5 is this right here. Okay, and if you look at the direction of the current, it's actually going this way, correct? So this would mean this has a higher potential compared to this VC over here. So it will be VD minus VC, okay? VD minus VC over R5. The value of R5 is 10 ohms. I'll just write down R5 first. And then that equals to I4. I4 is against applying voltage Ohm's law here. The voltage will be the potential difference between these two nodes here, correct? Where VE being 0. So I can just simply write VC, or maybe I can just write the whole thing. So this will be VC minus VE over R4. Okay, all right. Now I am going to plug in the values here. So if I plug in the values, I get VB minus VC. Oh, sorry, need to plug the values, right? Okay, VB, yeah, VB and VC are unknown, so we don't know their values yet. So I can just write VB, VC, yeah. VB, VC. R3 obviously is known. R3 is how much? 5 ohms. Okay, so I get 5 here. Plus VD, we already know that, right? VD was how much? 50 volts. So I get 50 here. Again, VC, this is something that we need to find out. Divided by R5, which is going to be 10 ohms, equals to VC minus VE is VE is 0, and R4 is how much? R4 is 4 ohms. Okay, and if I, just for the sake of the simplicity, if I multiply this whole equation by 20, so what do I get here? Well, the first expression in the term will then become now 4VB minus 4VC, right? If I multiply 20 by 5, divided by 5, so that gives me 4 as a coefficient, and then I multiply 4 by VB minus VC, so I get 4VB minus 4VC, correct? Okay, plus, again, here, 20 divided by 10 gives me 2, and then 2, I need to multiply that by 50 minus VC. So I will get what? I'll get 100 minus 2 VC equals to 5 VC, right? Okay, let's now rearrange the equation here, and I will get what? If I rearrange the equation, rearranging, okay, so I get 4VB, okay, minus 4VC minus 2VC, and then if I bring this 5-volt VC to the left hand side, so that would be minus 11 VC, right? Minus 11 VC, okay, equals to, and if I move this 100 to the right hand side of the equation, so it will have a negative sign then, negative 100, okay, and this is my equation 2, okay? So remember, this was our equation 1 right here, correct? And then also we got this equation 2 right here. And then we are going to simultaneously solve these two equations and find out the value for VB and VC. And there are multiple ways of doing that. You do whichever way you like it. So solving for VB and VC using equations 1 and 2, and I'm going to put those equations on top of each other here. So 40A, again, remember this is 40 amps, okay? 40 amps equals to 2VB minus VC, okay? So this was equation 1 here. And then equation 2 would be over here, which was 4VB minus 11 VC okay, and then this will get negative 100 over here, okay? Okay. All right, now what I'm gonna do here, I need to make one of the coefficient equal, right? And what I'm gonna do is if I can multiply this equation by 2, then I would have 4VB here, and then I already have 4VB here. I can solve these simultaneously, and then those may cancel out. So equation 1, I'm gonna multiply it by 2, so I will get what here? So 40 amps, this is negative 100 amps here. So 40 amps times 2 would be 80 amps, okay? 2 VB times, so that would be 4 VB minus 2 VC, correct? And then the bottom equation will be just exactly what it is, equals to 4 VB minus 11 VC, okay? Solving simultaneously, so you get plus here, minus here, plus here. 4 VB minus 4 VB will cancel out. 80 plus 100 will give you 180 amps here, okay? And then this negative 2 plus 11 will give you 9 VC, and VC will equals to 180 divided by 9, and that would give you 20 volts. So that's your VC right here. Okay, that's your VC right here. Now, putting next thing what we're gonna do is putting VC in any of these equation 1 or equation 2. I'll just take equation 1 over there, putting VC in equation 1. So 40 amps equals to 2 VB minus VC. VC is 20 here. Okay, all right. So 40 plus 20 equals to 2 VB, correct? And VB will equals to what, 60 over 2. So VB will actually be 30 volts, correct? Okay, sweet, we're getting close now. So we have VB now and VC now. We can go ahead and put that information on our circuit. VC here is going to be 20 volts. VB is going to be 30 volts right here. Okay, all right. We can now find out the current here. The current here, the I2. I2 would be what? Remember, you have 30 volt here. So I2 would be 30, sorry. So I2 will be equals to V over R. V is going to be 30. R2 is 5, correct? Similarly here, I4. Voltage here, I4 equals to V over R. V is 20 because you have, at this node, you have 20 volts over here, correct? 20 divided by 4. Okay, so here you get 6 amps and here you get 5 amps. Okay, so I can write down here I2 equals to 6 amps and I4 equals to 5 amps. Okay, okay, what else I can do? I need to find out the current that's flowing over here across I3. Okay, and that would be VB minus VC over R3. So I3 equals to VB minus VC over R3. Let's plug in the value for VB. VB being 30, VC being 20. 30 minus 20, and then divided by R3, which is 5 ohms. So I3 will be what? 10 divided by 5 is going to give you 2 amps, correct? Okay, all right. So I3 is going to be 2 amps, okay? Now, as I was saying, like, as you would start doing analysis and keep finding parameters, everything would start making sense. Remember, you have 8 amps coming in, okay, in this node. So you have 8 amps coming in. You have 6 amps going down, okay, 6 amps going down, and then 2 amps going here. So 6 plus 2 is going to make 8, correct? Okay, and similarly, you have, so 2 amps going in here, okay? You have this also coming over here. This is 5 amps. So what would be I5? Current entering equals to current leaving. Yes, folks, how much would be I5 here? Again, you have 2 amps coming here. You have 5 amps going out, okay? The total current entering should be 5. So that means I5 is going to be 3. And who was that? Who said that?
Teresa.
Teresa, awesome, perfect. So this is going to be 3 amps. So you can just write down here, I5 is going to be 3 amps, okay? Or the other way you could have done that is, you know this equation, right? I3 plus I5 equals to 4. You know I4, you know I3, and from that you can find out I5. But you know, when you can just done it quick by just analyzing your circuit over here, why would you just have to consume your time in doing all that? equation thing, right? So we have pretty much done everything here. We have find out the voltage across each resistor and the current across each resistor, and then the node voltages, which were basically VA, VB, VC, VD, VE. Everything is done, and that's how you would do it. Okay.